Hi everyone. So lots of people had questions about Lab 3, the gravity lab, and especially question 11, which was the one about the making a plot of the Earth, of how gravity varies as you get farther away from the Earth. So I thought I'd make a little video here, at least try to see if I could explain this in a way that would hopefully help people understand it as a takeaway. So I've got a picture of the Earth here on the whiteboard. And so the idea, just to give you, it doesn't ask you to do this in the question, but just to give you some understanding of what's going on here, right? So the idea is, if I think about the Earth as having a radius like this, right? So this distance I'm going to call 1 as 1 Earth radius, okay, is the distance from the center of the Earth to the surface. And that's what we normally experience, right, when we're just, much smaller than this, but when we're standing here hanging out on the Earth, or dropping our iPad on our face or something like that, right? When we're experiencing gravity on Earth, that's what we experience, is that distance away. So what the question is sort of asking about is, let's think about what happens if I use that Earth radii as my unit, right? So if I go like twice as far away, this would be the distance from the center of the Earth. Now, if I add in this piece, now at that point the distance is 2, right? And if I go out to here, now the distance is 3, and so on, right? That makes sense? Not that you can reply, but I'm going to ask anyway. Okay, so now with that picture in mind, so now I'm going to go over to the idea of making a graph of this. So if we think about, let's see, the question asks you to plot distance on the horizontal axis. So I'm going to do something like that. So this is going to be distance increasing like this. So I'm going to make that distance increasing that way, right? So this would be 0 distance at this end. And then it asks you to plot force going up like this. I'm discovering how hard this is to do this looking through my phone camera at the same time. There we go. Okay, so there's distance, and then this is going to be force plotted like that. Okay. So now, coming back to what I had over here, if I plot those and I think about the idea that gravity, the force due to gravity, right, it's got some constants in it, but in terms of what it's proportional to, so I'm just going to put the squiggly line to mean proportional. What it's proportional to, everything else is going to stay the same in this case, except it's proportional to 1 over the distance that I am away from the center squared, right? So that means that if I use units of distance, that this is going to be like 1 for 1 Earth radius away, then the force at that distance is what I'm just going to call 1 for purposes of describing this. So I'm going to label that force 1, okay? It's actually the force of gravity that you experience on Earth, but I'm going to call that 1 unit of gravity as the force that you feel at the surface. All right? So then that means if I go to twice as far away, right, so my distance goes to 2, then in that case, the force, if you think about back to that equation again, right? The force, if I'm twice as far away, is going to go to not 1, but 1 over 2 squared, which means it's going to be a quarter of what it was before, right? So that's going to be 1/4. So if I were going to plot a point here at 1, I'd have a point here that's where the force, when they ask you to graph it, that would be where the force lives at a distance of 1 Earth radius away, at a distance of 2 Earth radii away, where the force is a quarter of that, right? And if I were to go, for example, to 3 Earth radii away, then it would be down at 1/9. So that's going to be even much smaller still. It's going to be hard to show the scale on here, but you can estimate it. So that's a quarter, so that would be an 1/8. So it's going to be like something like this. So you can see it's dropping off really rapidly. And if I were to connect these dots, I could make a graph that's going to look something like that, right? Except it shouldn't actually hit the 0 line. Okay, something like that. And then the question also asks you, at what distance from Earth would gravity drop to half of the value taken from the surface? And so if I go back to here, if I need the force to go to a half of what it was before, then that means I need the distance to be just the square root of 2 smaller. So that would be, force would be a half at the square root of 2 of the distance, and so on. So I can answer more questions about that. If you guys have more questions, feel free to post them or send me an email. But I'm hoping that'll at least give you kind of a visual picture of what we're talking about for when you're thinking about that. It looks like most people did some version of at least getting the essence of it. So, credit-wise, you're all fine. But I just want to make sure that that was understood because a lot of people were asking about that. Okay? Thanks.